Welcome back, everybody. So, you need to send a message to the rest of your program, but you don't know who needs to hear it. Broadcasting or global message buses are designed just for that reason. They're similar to relays in that they aim to abstractly communicate messages among objects, but unlike relays, they send their messages to multiple receivers. In this tutorial, we'll make a broadcaster to notify the rest of our program when the player has increased their score. On the receiving end, we'll have a simple script that receives score messages, updates, and displays the player's current score. First, you may be familiar with global autoloaders, as defined under the project settings of your Godot 4 project. We will not be using this. Instead, we'll build our broadcasting using static fields. The advantage of static fields is simply that we don't need to remember to add our broadcast to the global autoloader. This step can be easily forgotten when copying our broadcaster to another project. So let's have a look at our broadcaster's implementation and see how we register senders and receivers for our objects. First and foremost, I do like to write large documentation comments, so this class is actually a lot smaller than it looks. It's actually fairly simple, in fact, as well. The most important thing to remember right now is that since we're not using an autoloader, having a class name for this class is very important. In my case, I prefix everything with CR. You can, of course, call this class whatever you want. I'll be using CR broadcast. We're extending object. Generally, that's a no-no in Godot. However, we are never going to be creating an instance of CR broadcast. If you're afraid that your users or your consumers of your broadcasting class might actually create an instance of a CR broadcaster by mistake, I would recommend changing it to extend ref counted so that it will clean itself up when it finishes. Objects, as far as I know, must be manually freed. And here's basically the heart of the system. I should go back to the relays. If you watched the relay tutorial, which is my first tutorial on this channel, we used object metadata to store receivers. Broadcasters do not have a particular object that they are attached to, so we have no object metadata to which we can work with. Instead, we're going to use a static var for receivers. When you make a variable static, it effectively puts it in a global state so that it can be accessed by any part of the program. You'll access it through the class name of whatever class you're working with. In our case, it'd be the broadcaster. So we could technically gain access to this by calling crbroadcast._receivers. Don't do that, though, because the underscore denotes we really don't want people reaching in here and dealing with it. Instead, we'll have send and receive functions which will manage that for us. So let's go ahead and start looking at those. Our receive function is actually pretty simple. It's going to take a message and a callable, just like a CR relay does. The only difference is there is no object to bind to, because the broadcaster, effectively where the relay is binding to an object, the broadcaster is the object by which binding shall happen. And as explained just a second ago, we're going to be using a static variable for managing our receivers. As usual, we are going to assert to make sure that we actually have messages, and we also want to make sure that whatever message we receive is of type CR message. That's just a formality. This is not a necessary line of code, but I like to make sure that only classes designed to be messages are being received. And this is another thing. If you haven't watched the relay tutorial, then this might seem a little strange to you. You may notice that message is of type script. It turns out that if you use a class name by itself, Godot will actually use that as a value, and its value type is type script. So we can use that to denote what message is being sent by just putting the script name, or the class name rather, which will translate into the script. We don't need an actual instance of our message in order to hook up to the broadcaster. Just the class name is sufficient. That's a fairly strange little trick, but it comes in very handy for these types of cases, and that's what we're going to use. All right, so how do the receivers work? Essentially, a receiver is a dictionary. It's got a key and it's got a value. The keys are going to be the message scripts, so those will be the class names. of whatever messages we want to receive. The value for each of these will be an array of callables. And as you can see, if we have a receiver, or if we don't have the receivers yet, then we go on ahead and we create our array of callables and we stash it for that particular message. In the case we do have the receivers already, or basically somebody else has registered that particular message, we want to add to it. So we go ahead and we just push back our callable onto the list. So what this effectively means is all messages, or all callables, all receivers for a particular message will be stored in the exact same array. And then once we get to our send, we'll get back to ignore in a second. Once we get to our send message, though, or our send method, we just simply grab the message from the keys of our receivers, go through each of them, and simply call that particular callable, that receiver, and we pass any arguments. I explain this in the relays, but we use send_v as a notation because we can't pass a variable number of arguments to a function, not yet anyway. I'm hoping that's a feature they introduce later. But because of that, we can pass the arguments we want to send to the function via an array. And if you do that, the Godot standard is to put a v at the end of it. I chose an _v, but apparently sometimes it's just a v. But anyways, the v denotes that the parameters will actually be an array of parameters rather than the parameters simply at the end of the function call. So essentially, we're just going to do the same here where we do callable.callv. Again, that variant means pass an array. And so we do the simple arguments. And that's basically it as far as sending and receiving. With the sending, you just basically pass the script or the class name of the message that you want to send, and you pass any number of arguments that message is expected to or the receivers are expected to receive. And that's it. These are all static called. So again, you will need no instance of the broadcaster. You'll just call crbroadcast.sendv or crbroadcast.receive. And that's as simple as it gets. The final thing is ignore. Whenever we call receive, we're actually adding to the receiver's list. So the broadcaster may outlive the object that it's storing receivers for. In that case, we have an ignore that allows us to unregister an object from the receiver list. It works basically the same way as the receiver, but instead of adding, it removes. Same signature, same parameter passage. And that'll come in very important later, and you'll see that. All right, well, again, if you came from the relay tutorial, then you pretty much know how a message works, but if you haven't, here it is again. It's basically an empty class. It's used specifically as a marker. I went ahead and made it extend ref counted in case somebody instantiated one by mistake. It will clean itself up. But at the end of the day, all you will be doing is creating your own messages, and you will be with their own class names, whatever you need them to be, and you'll be extending from CR message or whatever class name you decide to give your message. And that's it. Messages are very simple. Oh, and I should also state, these are the exact same messages as used in relays. So if you're creating a folder that has all of these classes in it, and you've already done the relay tutorial, you don't need this class. You already have it. The broadcaster's just reusing it. So you'll send the exact same messages for relay and broadcaster. There's no difference between the two. And again, you can change that if you want to make the two different, but I found no reason to distinguish them. All right, so I don't know why I have health.gd here. That's asteroid. Already made a mistake. All right, so this is our asteroid class. And effectively what we want to do now for our asteroid is anytime our asteroid gets destroyed by the player, it would be kind of cool if we could send a little message out to the rest of the application to say, hey, an asteroid was destroyed and it's worth a certain amount of score. In this case, I have it as an export var, score award. That'll be the amount of points the player is awarded every time an asteroid is destroyed. Since it's an export var, that does mean in the inspector I can change that value. By default, it will be 100, but there might be bigger asteroids, such as we created in the last tutorial, which might be worth more. In fact, they might be worth 1,000 instead of 100. So this allows you to modify that on a per object basis and becomes very handy. So highly recommend doing it that way. The only thing we're going to be doing different here is we're adding a piece of code in our destroy, that simply broadcasts to the rest of the application that score has been added. And you'll see here that we have a score manager.add score message. We haven't defined that yet, but I'll show you what that looks like in the future. But essentially, that'll be the message that we want to send. And we're going to just send as our parameter. Notice it's in an array. Notice it's in brackets, square brackets, score award. Those square brackets are important. Again, you need to send those as an array so that it gets to the receivers correctly. Otherwise, receivers will not call. Don't forget those square brackets. But that's essentially it. We're not sending to any particular object. The relay would have had a parameter before the message that is the person who's receiving or the object that's receiving. But in the case of broadcast, we're sending it message or globally to the entire application state. So if there's anybody on the other end who's receiving that particular message, they're going to get notified that there's been a score change. And I'll just go to the end real quick so you can see basically it's the same as it always was. There's not a whole lot left. You can go ahead and pause the video if you're making this for the first time. Probably best to follow the tutorials in order, though, if you want to completely replicate this entire project, at least to the best you can. Then we'll go ahead and move on. And here's the score manager itself. So I've gone ahead and made this a node. In the vein of components, I felt it was just best to make it a node that I could slap somewhere, and then I can essentially have this export var down here that will be the label. And so effectively that'll be the label that is changed every time the score is updated. And also down here we have the score itself. And I've made that private because there's really no reason not to make it private. Anytime we modify the score, we're going to be using a function, and it's not that hard to create a receiver. So if we want to see what our score is from another part of the application, well, we can either broadcast the score, which is now an option, or we could just simply have a get score function that returns the score value. That way I'm not reaching into the fields and the nitty-gritty of the score manager. That's all technical details that the score manager needs to be privy to, but the rest of our application does not. So that's my justification. But here's the important thing. Class add score message extends CR message. This is the message we saw earlier over here. In our CR broadcast SynV, we have score manager.add score message. That's the same class. So whenever we receive a score update, this will be the message that is sent, basically. And we can hook that up over here. This is essentially most of the class. Yeah. Okay, so we're doing a couple of things that have to be done together. First, enter tree and exit tree. If you're not familiar with those, whenever an object enters the tree, this function will be called. When it exits the tree, exit tree will be called. These two things can happen on instantiation of an object after a node calls add child on that object. And when an object is freed, exit tree will also be called. So we're essentially using enter tree and exit tree as sort of initializers and cleanup code. And that's very important because first for enter tree, we want to do CR broadcast.receive, add score message, add score. So basically anytime we receive the add score message, we're going to call this add score function. And it's pretty straightforward. All it does is add to the score, and then we just set the score label to the current score. And remember your string cast there to make sure it actually compiles and runs correctly, and you should be fine. But effectively, that's all that's going to do. So basically, our score manager is the receiver of the add score message, and then other parts of the application are going to fire off this message as the player receives score. And when the player does, we call this function via our receiver and add to the score and display it. And that's it. Now, once this object leaves the program, when it is freed, when it is destroyed, lifetimes matter. We have to call ignore and remove the message and, of course, the receiver. That is vitally important. With the relay system, generally speaking, you could get away with just having a receive and the ready and never calling ignore on the relay object, because those objects tended to live long enough, or the lifespans were usually pretty close. It probably still was best to use enter tree and exit tree for the relays as well, but you could get away with not using them in a wide variety of cases because of how object lifetimes worked. In the case of broadcasting, that simply will not do. You need to call exit tree because the broadcaster is almost guaranteed to outlive every object in your program. And because of that, temporary objects that register to the broadcaster, register receivers to the broadcaster, need to clean themselves up when they go out of scope. Otherwise, the broadcaster will be accessing an object that no longer exists, and that probably is going to generate a runtime error and crash your program. So remember, exit tree, ignore. Enter tree, receive, exit tree, ignore. All right. So that's basically it. I mean, the broadcasting system, we now basically have a score system in place, and it should work just fine. And we'll test that in just a little bit. There's one other piece of cleanup. I didn't go over a huge amount into the health system in the last project or in the last tutorial, but this time around, there's a small bug in it. So we're just going to go ahead and fix that real quick. It's on this line 36, probably line 36 anyway, unless you've made modifications to it. This is the part in set health where it does the check to see if health should be set, and it returns early if the conditions are not right. We're going to add a new condition to that. First and foremost, the current condition, put parentheses around. And before that, we're going to check to see if health already is less or equal to 0. If it is, we're going to return early. The reason for this is because multiple projectiles can hit an asteroid before the asteroid terminates itself. And so you could end up with a double scoring when you meant a single scoring, e.g., your next shot will be a kill shot, but in that frame, 2 projectiles hit the asteroid. You end up getting double awarded score. In this way, the first asteroid or the first projectile to blow up the asteroid will be awarded the score, and the second one it'll kick out because it'll notice that the health's already less or equal to 0. So that's just a little bit of cleanup, so you don't end up with a weird scoring bug in it. And that's basically it. Here's the thanks for watching screen, but obviously you probably want to see how it's going, so let's go ahead and check that out, and then we'll get back to that thanks for watching screen a bit. But yeah, if we go over here, you'll notice in the top right, I've got my score, and if I fire, boom, there I go. I've got 100 points, and I can keep doing that. You'll notice I can fire, 300 points, so everything seems to be working just fine. I've also, like I said, made the larger asteroids worth 1,000 points, so if I can blow one of these guys up, there we go. Now I'm at 1,300 points. And that is essentially all there is to it. So again, let's see. Thank you again for watching. I hope you enjoyed the video. I consider components, relays, and broadcasters the trifecta of good design in Godot. And as you use them, you'll notice your code is more concise, reusable, and easier to reason about. Also, I personally found that the code refactoring is less scary, as I know that smaller components tend to not directly interfere with the code around them. And relays and broadcasters let the receivers handle code in the way that works best for them. Add these to your coding arsenal and make great projects, guys. If you have any ideas for future tutorials, drop them in a comment below. I had some ideas for tutorials to kind of set up this channel with, but they're slowly dwindling, so I'm definitely open to new ideas if you've got them. I look forward to seeing you in the next one. God bless, guys, and thanks.